Hi, everyone. We're actually a couple of minutes early, and I think we're going to give a couple of minutes pass before we actually start, because I think some people will be probably running a little bit late, particularly with the change in times that we unfortunately had to make after this was announced. Okay. But while we're waiting, it'd be interesting to kind of find out a little bit about the attendees' backgrounds and what they hope to get out of this. So there's a chat window where you can type stuff. Hi, I'm Rusty. I work for Blockstream. Today's presentation is going to be about half an hour of content, but I'm hoping for plenty of questions so that you can direct where I should spend the most time. And so, yeah, if you ask your questions in the chat box, then we have a couple of co-admins, Mario and Daniel, will be kind of sorting the questions to direct through to me if we get flooded by them. Okay. Sorry, I realized I was still sharing my screen rather than the video. So, hi, everyone. Hugo, Annie, Viraj, Kunal, Sandra. Excellent. Cool. Okay. All right. So I thought what we would do today is we'd start from nothing, right? We will start with like a new machine, and in my case, this is an Ubuntu machine that we're running on. We're going to grab the Lightning source. We're going to build it. We're going to set it up. We're going to set up a little test network, and we're going to write a plugin. So basically, it's going to start from an empty directory and work our way through to the end there. I think that's kind of useful to give you a feel for, we're going to play around a little bit with C Lightning, give you a feel for how Lightning works and how our implementation works, and get you comfortable with the commands. And from there, we can take whatever questions we want. And feel free to interrupt during the time with questions, because I think that will help as well. Okay. I should warn you in advance that it's 5:30 in the morning here in Australia. So if my typing's even worse than usual, that is probably why. Okay. Okay, so I'm going to share my Emacs screen now. Okay. There we go. And you can see actually on the screen my cheat sheet of what we're going to do. So I will actually open a shell here. And the first thing I'm going to do is a Git clone. This is basically grabbing the source from where it's hosted on GitHub. We're getting the whole thing. That's created a directory called Lightning. Here it is. Now, normally what you do first is you'd look at docs install, which basically walks you through all the requirements. So in particular, you would usually do the installation line that you can see here. Obviously, this is my development machine, so I have all these prerequisites installed. So let's assume that I've now typed that and all those packages have installed. You will also need a copy of the Bitcoin D. So although you don't need it synced to the main chain, you obviously would want that for production, but for testing, that's completely unnecessary. So you just need it installed somewhere. So now we've done that. You basically just configure and build. Now, the reason that I prefer to grab from Git rather than taking one of our prepackaged releases, there are a couple of reasons. The first is that that gives you the very latest bug fixes and latest features. In particular, when you're writing plugins, we're still fleshing out a lot of the plugin APIs. So if you're on the latest version, you're going to get the new hotness with all the richness that you can create with plugins. We found that to be quite useful. The other reason is that, frankly, it's really useful to have people testing the latest Git release. It means that you get fixes and updates faster if you find something, or if there's something that you want enhanced. So frequently you'll find, there might be some feature that would have made things easier for you. You can submit an issue on GitHub or even a pull request if you're feeling adventurous, and that can take can be quite a fast loop to get updates out. So we definitely like our testers to be on the latest Git. Okay, so there we have built C Lightning. It's fairly straightforward, and the normal first thing to do is to run lightning D. You can, of course, do sudo make install at this point, or if you set up your permissions, you don't need sudo. But you can also just run lightning D for test reasons out of the directory. I don't install lightning D on my machine because, of course, I'm developing all the time. I don't want to get confused with an old version that's installed somewhere versus the version of my directory. So you can run lightning D. And the first thing it will do is create the default directory, the .lightning directory. But it will immediately complain that Bitcoin isn't running, it can't reach Bitcoin D. Okay. So normally at this point we would run up Bitcoin D and connect Lightning to it. But there's a cheats way of doing this. And I'm going to show that to you. In the contrib directory, there's a script called startup-regtest.sh. Now, regtest mode for Bitcoin is a special mode where it's trivial to generate blocks. And it's a great test mode for trying out things. And we use it so much that one of the core contributors, Lisa, created a helper script here that basically sets up your Bitcoin D and sets up 2 Lightning nodes connected to it so that you can run simple tests. So you do need to set a couple of environment variables. You need to tell it where your Lightning source is, the path to Lightning D, and you need to tell it where your Bitcoin directory is. And then you just source that, and it will create a couple of commands. Most important is the startln command. You type startln. It actually starts up 2 Lightning nodes, and if necessary, starts up Bitcoin D. Okay, so we now have 2 Lightning nodes running, and it gives us a couple of convenience commands. You can see here. It gives us L1 CLI, which points at the first Lightning D, and L2 CLI, so we can control both of them at once. Okay. Now what it's actually done behind the scenes is create these directories L1 and L2 regtest in temp. And that's where C Lightning lives in this case. You can see there is the config file. We have a gossip store with no gossip in it because there's no Lightning network yet. We have a database file, the SQLite3 file there. So, and of course we have a log. If we look at the config, just quickly, we will see it creates a very simple config. It tells it it's on the regtest network. It starts it up as a daemon. It sets the log level to debug. That's useful if you're doing testing, but it does produce a very verbose log, and of course it tells it where to put that log. Okay. I should point out at this point that there is a man page which describes all the options that you could possibly put in your config option. Let me just, normally you could just type man lightning d config, but because I haven't installed it, I need to use the -l flag to point it at the actual raw file. If I get that right, man.config.5, of course. Okay. Okay, so here's the Lightning demand page, which tells you in more detail than you could ever want all the options and bling that you can add to your Lightning node. I do want to highlight the very first option in the man page. This is allow deprecated APIs. And by default, when you start up C Lightning, you get all the APIs, including the deprecated ones. We do give at least 6 months notice before we deprecate APIs if we're changing them. But if you set that allow deprecated APIs to false when you're testing, that ensures you don't accidentally use some API that's about to go away. So I do recommend when you're developing a plugin to set allow deprecated APIs to false and make sure you don't accidentally stumble over that. Okay, so there's our options. Now, I will just, let's start a channel. Okay, so our screen's a bit messed up there. Okay, so what we're going to do is we're going to create a channel between the two test Lightning nodes. Okay, so in order to do that, we need some Bitcoins, and fortunately, that is really easy to do in rich test mode. We get new address, which gives us an address to use, and then we simply tell it to generate to address 101 blocks to that address. And there you go. We've just mined 101 blocks on Rake test. So that was easy. If we get our balance, we should have get balance. We now are the proud owner of 50 test Bitcoins. Okay. The reason we had to generate 101 blocks is that when you mine a block in Bitcoin, it takes 100 blocks before you can actually spend it. So there you go. Okay, now we need to get that into C Lightning. So if we do ln1 CLI, sorry, L1 CLI, we can do new address. Okay, so this is giving us a Bitcoin address, a modern SegWit style Bitcoin address. And we can tell Bitcoin D to send to address to that address that we've got. And let's send 10 Bitcoins. Okay. Now, of course, it's created that transaction. We actually need to mine a block so that it's confirmed. Let's generate another block. Okay. Now, we should be able to see that in list funds. The issue here is, of course, that Lightning D asks Bitcoin D every 60 seconds or so what's going on in the network, have new blocks appeared. And so it can take up to, we've got the worst case, 60 seconds before we will see the funds appear. There we go. Okay. So here we have 10 to the 9 or a billion Satoshis. But inside the Lightning Network, we denominate everything in millisatoshis. So we have a trillion millisatoshis to play with. Well, that should be plenty. Okay, so if we switch back to our plan, okay, let's look at L2 CLI. Our other node. Here's the node. It's created a random ID and a random alias for it. C Lightning by default chooses NSA style names for its aliases, but you can customize that, of course, in the config file. Now let's connect the two. So if we tell L1 CLI to connect to that ID and the... Now, normally you can just tell it to connect to an ID, and the Gossip network will have spread all the information about where nodes are and how to connect to them. In our case, we haven't set up the network yet, so we need to explicitly test it, so explicitly tell it where to connect to, and there we are. It is connected to the other node. Now we can fund a channel, and let's use 100. No, let's let's spend some of our million Satoshis. Okay, so there's our MSATs. We could also do that in BTC. Well, we couldn't do that many BTC, but we could do it in BTC, or we could do it in SATs, so you can denominate. But in this case, we'll do it in MSATs. And if I spell it correctly, less fun, more fund. There we go. Now again, of course, we'd have to wait for a confirmation. So we generate another block. And if we ask L1 CLI, and we tell it to list peers, we can see that this is the first peer that we're connected to. It has a channel, and the channel is awaiting lock-in. So again, it could take a little bit for it to see the confirmation. Now in reg test mode, C Lightning defaults to only requiring one confirmation for channels to be confirmed. If you're playing on the real network, the default is 6. So you'll make sure that it's that the transaction is well confirmed before you can use the channel. Okay, there we go. We're now in status channel normal. Our funding transaction is locked in, and we've got a fully functional channel. Okay, so we've got a channel between the two, but let's actually check that it works. Okay. In the Lightning world, payments are done by presenting invoices. So we use the invoice command on L2. We're going to tell it to generate an invoice. Now, an invoice requires 3 things. It requires, obviously, an amount, although that is optional. You can create an any amount invoice if you want to. Let's do 11111111 MSATs. It also requires a label. A label must be unique. And the reason that the label exists and is unique has to do with robustness. Because we're developing C Lightning as a basis for a robust server-side implementation of Lightning particularly, it's important that you handle cases where your higher level, say your web store, submits a request to create an invoice, but the power goes out just after you submitted that request. And now you don't know whether or not it has processed that invoice or not when it comes back up. By having a unique label, that means that you can actually check if that label exists, then you have definitely created the invoice. And if it doesn't, you can create it again. So you can give the label, we can call the label anything, we call it label 1. We also add a description. So the description is human readable, and it's something like, this is payment for test, right? Okay, there we go. We have this bolt 11 string, which is the important information in this. Now you'll notice that we also have a warning about capacity, that no channels have sufficient incoming capacity to pay this invoice. Now that isn't strictly true here. Obviously we have an incoming channel. We should be able to pay it. In this case, what it's strictly saying is we don't have a public channel that is incoming. In the Lightning protocol, it takes 6 blocks before you're allowed to announce to the world that you have a channel. It has to be that deeply confirmed. We don't want to see channels that are likely to be reorganized out. So we don't actually have a public channel at this point. And in fact, C Lightning is even a bit smarter, that even once we did have a public channel, it would notice that there are no other public channels to that node. So it's unlikely that in a real network that anyone would be able to use that channel to pay us, and so it would still give a capacity warning. But we can ignore the capacity warning for now. And there are a couple of ways we can use this invoice. We can pay it immediately, but we can also decode it. Now, there are 2 ways to decode it. There is a command called DecodePay. You give it the invoice, and it breaks it down into all the parts and decodes it for you. You can see the network it's on, which is reg test in this case. You can see the time it was created. That is a Unix timestamp. And the expiry, in this case, we default to having invoice expiry of 7 days. So you can pay that anytime in the next 7 days. It shows the payee, which is L2, our second node, the amount, and that description that we put in, the payment for test, appears in the invoice. So the invoice is a contract that says, and it's a signed contract because it's digitally signed here, that says, if you pay me this amount for this thing I'm describing, then I will give you a receipt that proves that you paid it. In particular, I will give you the secret that hashes to that payment hash there. The idea being that somebody can produce that. If they can produce that pre-image, they can prove that this invoice was paid, and therefore you owe them whatever it was you described. Okay, so there's our invoice. It seems good. So let's get L1 to pay it, just like that. And there we go. We've made a payment. Obviously, with two nodes directly connected on the same machine, the payment is almost instant. So if we ask L1 for list pays, we can see all the things it's paid, in this case, with one thing. Importantly, you can see status complete here. Okay, and we've got the payment pre-image, that secret that we swapped for the millisets. So there's the amount we sent, and there's the invoice that we paid. If we ask L2, we can also do list invoices, and it shows us the other side. Here's the invoice. The status is now paid, and it shows us things like the millisatoshis received, because you can actually overpay an invoice. Sometimes that's important if you're trying to add some noise into the payment amount to make it more difficult to trace where the payment's going. You can actually add a little bit of noise. So you do get an amount received field. You can tell when it's paid. You can see the description and when it would have expired. There's also a wait invoice command that will basically wait for an invoice to be paid if you're trying to do back-end work, and wait in any invoice, which will basically wait for the next invoice to be paid. And then you can do list invoices after that. So we have a working channel, and we've made a successful payment. That's pretty cool. So I think at this point, we're ready to make our first plugin. Although I should point out that there is, sorry, L1 CLI, there is a help command. And help basically does what you expect. It lists all the different commands that are available in C Lightning, and it's grouped sort of into categories, Bitcoin channels, things like that. So and there's a few developer commands. If you built your test node, your nodes with the enable developer configure option, you'll end up with a lot more developer options that are all extremely dangerous, but are great for testing obscure scenarios. Okay, so should I pause before we dive into building our first plugin and see if there are any questions that people want answered?
Hey, Rusty. Yeah, there are.
There
are a bunch of questions in the queue.
Okay. I was looking on the Q&A tab, and there's nothing there, so I will take a look on the chat tab.
You gotta look in Q&A under published.
Oh, right. Okay. Sub-tab published. Oh, there we go. Okay. Can you adjust the default config on mainnet to below 6 blocks? You can. Yes, you can definitely. If you look in the Lightning config, you can alter that to be lower or higher if you want. But the protocol rules, nobody will accept an announcement of a channel less than 6 blocks old. So Pierre and I can agree that the channel's ready earlier. Of course, both sides have to agree. So if you're saying I want 3 confirms and they say I want 6 confirms, you're still gonna have to wait 6 confirms before your channel's really open. But the broader network won't accept an announcement of a channel less than 6. So if you're looking at receiving incoming payments, it's going to be difficult for them to do until you're 6 deep anyway. Now, how do you overpay an invoice? Okay, this is a good question. You can actually do it manually. There are ways to create a payment manually, which I'm not going to go into now. The pay command just does it all for you. Looks up the route, creates the route, figures out how to pay. But you can actually create a manual payment using one of the lower level commands and actually tell it explicitly how much to pay on each hop. And that way you can actually overpay a payment. The spec says that you have to allow them to overpay by a factor of 2. And you should reject if it's more than that. Because I figure if it's more than a factor of 2, it probably means they've done some terrible error, like they put in Satoshis instead of millisatoshis, or God forbid, Bitcoin instead of millisatoshis. And you're probably not doing them a favor by accepting gross overpayment. In fact, C Lightning itself will fuzz the amounts. That was accidentally disabled in the last couple of releases, but it will be coming back. Mainly because amounts tend to be a round number. And if they're a round number, it becomes a lot easier for you to derive, to make a good guess as an intermediary on where that amount is going, how many hops away. You can kind of guess, well, I know what fees everyone charges, so I can guess that it's 3 hops away from me, so I can guess perhaps where it's going. If you fuzz the amount a tiny bit, users don't really care. You're talking about fuzzing by like 0.1%, things like that. But it just masks the length of the path effectively. So that's the reason that we overpay on fees. Okay. Did that answer those questions? Right. Plugins seem to go in their own category and help. So yes, plugins all get grouped together. And we did wonder whether plugins should have their own individual categories. And in fact, you can add categories, and plugins could advertise theirs as their own category. So if you have a plugin that has lots of options, it can actually create its own category and help automatically. But by default, when a plugin offers an option, it goes straight in as under plugins. Okay, cool. Well, now we've kind of got a feel for how this works and how to drive C Lightning and the kind of average flow that you'd get. We're actually going to do what everyone does when they write their first plugin, and that is copy from contrib plugins hello world. This is actually not that simple a plugin anymore, but we're going to delete most of it, and we're going to just save it here. Okay. This plugin is written in Python, and the Python infrastructure for plugins is pretty mature. It is shipped with the C Lightning as part of the PyLightning library with C Lightning. So it's well maintained and it's up to date. And it uses a fairly simple method. You create decorators here. And you say, I have this plugin method hello. It takes an optional name. It has this default. The documentation strings become the help in the messages. And basically, the function just returns something that gets turned into a JSON response. Okay. In this case, the plugin also has an option called greeting that defaults to hello. Okay. So that is our plugin. Now this is an important step. If we don't make it executable, it will refuse to run. Okay. Now let's go into our L1 config and add it as a plugin. So plugin equals plugin. I've got the line here. Okay. Okay. There we go. There's also a plugin dir config option, which basically says scan this directory for things that look like plugins. But you can also just use plugin to specify an exact file. As of about 3 days ago, there is actually dynamic plugin support. I decided not to do that because literally while I was testing this, I found another bug, which is now fixed. So it's still a little bit bleeding edge, but it will be in the next release. So you can dynamically add and remove plugins. One reason that I don't dynamically add it is that I want it here in the config, so it's persistent. So we'll do this the old-fashioned way. We will add our plugin. We will we will switch back to the next shell. Okay. So we've got our plugin, and then we'll use stop ln to stop our nodes, and then we'll start them again. Oh, okay. Right. It couldn't find, because I didn't do a make install, it couldn't actually find the plugin directory. So let's stop ln, let's kill everything. And what we'll do is we will set export Python path. So this hack will allow Python to find /contrib /pylightning. Okay. Now if I start ln, there we go. Okay. So if we do ln1 CLI help. L1 CLI help, sorry. We should see underneath plugins, we now have this, hello. So it's integrated the plugin into the help. It's taken the argument name here, name, and made that printed as an optional parameter. You can tell it's optional because it has a default. And so we can do L1 CLI help, hello. And it's hello world. We can give it a name. Hello everyone. There we go. Okay. So that's our plugin in action. Now you've also noticed that it added an option. So if I run Lightning D, I give it the Lightning dir pointed to the right place, L1 reg test, and I type -- help. You'll see down the bottom here, it's got a new argument, -- greeting. That means I can use -- greeting on the command line when I start it, but it also means that I can put it in the config file. So in our config file, we could put greeting equals some other greeting. Okay. So this shows you kind of how integrated plugins are. From a user point of view, there's no difference between CLightning itself and the plugins that surround it. And this is really important. It means that we can concentrate on making CLightning like the most solid and robust base that we can, and we can do more flexible and extensible things on top of it. In fact, the pay command itself that you saw me use earlier is in fact a plugin. It was originally part of CLightning, and we moved it out because it does actually do some quite complicated things, and it made more sense to be a plugin. It's in fact a plugin written in C, but there's no reason that it couldn't be written in Python as well. But it also means that you could write your own pay plugin, which may have different characteristics. Okay, so there's our greeting, there's our plugin working. But that's a pretty boring plugin, right? So, it works, but it doesn't do anything interesting. So we're going to actually make it a little bit more interesting. We're going to use the Lightning millisatoshi plugin. This is the thing that handles all the MSAT. It handles parsing of millisatoshis. I strongly recommend that you do something like this, whatever language you implement your plugin in, because consistent handling of financial amounts has been a bug that has bit just about everyone in Bitcoin. It has certainly bitten us before. I have funded channels by the wrong amount in early versions of CLightning because the channel funding was in Satoshis, not millisatoshis, which is one of the reasons that we changed everything to be consistent. So if you have consistent money handling, it just makes things a lot easier. Now we're going to call our plugin method balance. So we're going to write a balance routine, which just prints our balance. So we change the name. We say this gives you your node balance. Okay. Now, a very common thing, you can see a log line there. We don't need an option anymore. Okay. What we're going to do is we're going to do an RPC call. So a very common thing for plugins to do is to actually call back into CLightning to get information out again. And of course, plugins can also call other plugins and build on those. So we're going to go s equals. Now we're going to give two parts to our balance. We're going to give an on-chain balance, which is how many funds you've got on the Bitcoin chain, and also like a Lightning balance, how many funds you've got available in channels. Now, if we do a list funds, star shell, L1 CLI list funds. Oh, you can see that it looks like this. There we go. It lists the outputs and it lists the channels. So what we want to do is we want to iterate through these outputs, and we want to add up these amount MSAT values, which shows how much money we've got, where the output is in status confirmed. And then for our online funds, our Lightning funds, we want to iterate through our channels, and we want to look at the our amount MSAT field here, which shows how much we're holding in the channel. Okay, now to save me typing, I have done this before, and it works something like this. Okay, so I call this reply. Okay. You can see it basically summing up those fields where the status is confirmed. And the default, if there's nothing, is millisatoshis of 0. And similarly for the Lightning amounts. And then we return a reply. Okay. Now, if I haven't made some horrible typo, I should simply be able to restart. What's it called? Shell? Yeah. Stop ln. Start ln. Okay, and L1 CLI, balance. L1 CLI. Oh, great. Okay, so we got an error. Okay, now this is an opportunity to show you what happens when you get an error, and that is you look in the log. We've gotten the final line of the Python error, but if we look in the log here. Log down the bottom, you'll see the full traceback. So anything that your plugin spits out to standard error gets logged as coming from your plugin. And so basically we can see on, where are we? There we go. On line 12 for our plugin, Rusty made a typo. Okay. Plugin.rpc.listfunds. Okay. No. Stop ln, start ln. There we go, and let's try balance. There we go. Okay, so it's given us our balance, and we've written our first plugin. That's pretty nice. If we do help balance, it actually tries to look up a man page for that. So the first thing when you ask for help command, it refers you to the man page, which is more detailed. If that fails, it falls back to just asking Lightning D. And so we can see this is our darkstring comment. There you can see our category and the verbose description, which is the same as the existing description. Okay, so, right. Well, that's a pretty horrible output. So we can neaten it a little bit by changing it to be to a proc string. This gives like a 3 decimal place approximation. So let's do that. Stop ln, start ln, and get our balance. And there we go. That's a little bit prettier. It has done some rounding, but we've got a little bit prettier output at that point. Okay, so now that may be readable to you and me. We've got 10 Bitcoin, and we know that's a lot, but it's not all that useful. So really what we should be doing is probably giving some like fiat representation as well. So fortunately, this is Python, so it's actually surprisingly easy to do. We're going to import a couple of packages, which do the magic for us. And we're going to call out to one of the, there we go. Okay, we're going to call out to one of the places that will offer an API that does this. BitcoinAverage.com, for example, have an API that converts like, currency equals, let's default to USD. Prefix equals USD dollar. There we go. So this basically just gets the Bitcoin price. And from there, we can actually do, we need to float that to BTC. So we convert to BTC, turn it to a float, multiply it by fiat per BTC. Okay, there we go. And I've put it into a formatted string with a prefix in it, so it looks pretty. Okay, again, we'll do the same thing for a Lightning balance. Let's to convert to BTC. Times it by the fiat conversion, whatever that was. Okay, now if I haven't made any typos, let's see if this works. Stop. Start. Okay, well, it started. That's always a plus. If you've got any gross typos in your Python, it won't get to that point. And let's look at balance. Okay. Whoa. Okay. I messed up. What did I do? Oh, I deleted the line where I did this? Created the dictionary in the first place. Okay, there we go. Okay, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, now that pause, there we go. We have our on-chain and on-chain balance. Now that means I'm test rich. This is, of course, our test USD, not real USD, so I'm afraid I don't have $100,000 on my laptop. That pause is there where it's doing the web request. Now, obviously, this is a very naive plugin. It's going to do a web request every time I ask for the balance. You'd probably want to poll over some longer period in practice to avoid that delay. But let's try changing the currency. If I want to feel richer, I can do it in Australian dollars. So prefix equals AUD dollar. Right. Okay, there we go. We feel even richer now. I have $12 in the chain and like 138,000 made up Australian dollars. Okay, cool. And I think that emphasizes to you why plugins exist. Plugins can do things like web requests and reach out, serve web pages, do AI, deep learning, whatever it is that they need to do, which isn't really stuff that we want in a robust core of our implementation, and yet are really important and really usable. So this was the reason that we decided to implement this whole plugin infrastructure, is that you can then go away in any language that you choose, and there's C, Go, Python, obviously. In fact, I believe someone's done some work in JavaScript to write plugins. And you can obviously create your own infrastructure that builds whatever you want using a fairly simple API on top of C Lightning itself and interacts. And that API is becoming richer all the time as people come up with new things that they want to do, and we expose more functionality to plugins. Okay, cool. So I know that was kind of like a blast there, so I'm going to go back and pause for a moment. I might stop screen sharing and return to video. Okay. I know that it was kind of cool to see me typing in Emacs for all that time. Hope you're still awake. So let's start at the top. Hugo asked, is it possible to pay an invoice with many payments? It's interesting, actually. That's what I was working on just before. There's an update required to the specification to allow you to use multiple payments in parallel to pay something. We call it, we now call it multi-part payments, but it used to go by the name AMP, A-M-P. We love our energy and lightning puns, hence the name AMP, atomic multipath payment. So that's something that's coming in the new revision of the spec. It's been drafted, and I expect an implementations to start reaching fairly soon. Obviously, then both ends will have to support it. So the end receiving the payment and the end sending the payment will both have to support multi-part payments. But that's certainly something that we've seen surprisingly important for people to basically be able to split their payments into multiple parts. So at the moment, it needs to be a single payment that covers the whole amount, but fairly soon in the next few months, we will start to see that rolling out that you can pay it in multiple parts. There's a question. Can you expand on how a plugin could call an API? Oh, I see. I'm reading these backwards, maybe. Right. Can you expand on how a plugin could call an AI? I mean, basically, there's already a plugin called Autopilot, right? That's designed in theory to like maintain your channels for you, right? So it can choose which nodes it should connect to, which nodes it should create channels with, how much fees it should charge for those channels for things routing through, when it should close them down, et cetera, et cetera. So that is sort of an infinite problem. You could certainly do any number of like back-end processing for that kind of thing. So that's an example of a plugin that could use an AI. But there's obviously at the higher level, it depends entirely on what your application is, but it could be arbitrarily complicated. Okay, can you build full smart contracts in LN using plugins? Well, anything a Lightning Network can do, you can pretty much access using plugins. you can certainly do some really interesting things with plugins, and I think we're going to see more people explore that. But the term smart contracts is something that is probably too vague for me to answer in this forum. But if you have specific ideas, I'd be happy to answer whether or not that is possible. Okay, Ugam asks, the network won't accept below 6 blocks. Is a C Lightning software requirement or a spec requirement? It's a spec requirement. In the spec, you don't accept broadcasts of, you don't accept announcements of channels that are less than 6 blocks old. It's simply for the robustness of the network. Okay, so Vivek says, I recall Christian showing a get route method. Is it still possible to simulate routing in rig test? Yes. I've only set up 2 nodes, but you can set up a lot more nodes. My laptop should be able to handle a couple hundred nodes pretty easily now. So you could actually create a massive number of nodes and actually connect them to each other. But there is actually also a cheat way of doing it. You can have a canned set of announcements that basically you can feed into a node that tells it about this entire network out there that exists. It just happens that it's not connected to it, right? So for things like simulating routing, which is what we did with the Million Channels project, we actually created this whole canned blockchain that, as if it had been created by 300,000 nodes. And also all the gossip messages that you would send. So you'd connect to this network, you'd get all this gossip messages, and you'd find out about these million channels that were out there. So that's how we did that, and that is all done in Rake test. I think, how many channels can be open between 2 nodes? Okay, this is actually a really good question. So in C Lightning, we only implemented a single channel between 2 nodes rather than implementing multiple channels. And the reason is that it's important for the spec that we upgrade so that you can upgrade an existing channel, right? So at the moment in version 1.0, there was no mechanism to upgrade a channel. So you create a channel. If you want to increase the size, you tear that channel down and create a new one. This is obviously suboptimal. One of the things in 1.1 is this ability to upgrade a channel on the fly, right? You can add funds. You can remove funds from a channel as well. Basically, you can pay someone on chain from a channel that is between the 2 of us, or we could put some money into cold storage, whatever it is. But we could also bring money on and add to the channel. That's where we see the Lightning Network going. That's obviously something that we want to do. Now, resources are finite, so because we haven't had that in the meantime, a number of people have gone and implemented multiple channels. Now, multiple channels are less efficient than having a single channel. So we really, really want to spend the engineering effort on getting that channel upgrade, splice in and splice out of existing channels working, rather than spending time implementing multiple channels. And I know that unfortunately it's taken longer than we would hope. In the long run, that's how we'll have multiple channel support. But also from the point of view of the network itself, it's healthier for the network if you open channels to multiple different peoples rather than opening multiple channels to a single party, because it makes the network more robust. And it's a better experience for you because now you're no longer relying on a single counterparty, you're reaching out to multiple people. So the one advantage that it's had of forcing you to have a single channel per peer is to think harder about your peer selection so that people have connections to more peers rather than doubling down on the same central point of failure. Okay. Bernard asks, multipath or multipart? Both. If we're talking about payments that can be split into multiple parts, those parts ideally will also go down different paths. In fact, there's very little point in just having multiple on exactly the same path, right? So you'd want it to go all the way around. Okay, cool. Okay.
There's one more, Rusty.
Yeah. In what order are we getting these features? Okay, splice channels, watchtowers, Coinjoin, channel opening. Okay, right. Oh, wow. That's a good question. Splice channels requires more specification work, and that is not actively being worked on because there's a whole heap of other things in the spec that are even more important that are ahead of it. So I can't even give you a sort of a vague estimation for that. Watchtowers, some implementations already have watchtower support. I'm not incredibly delighted. I mean, the watchtowers at the moment are a little bit simplistic, and I would like them to get more sophisticated. On the C Lightning side, because we look at mainly so watchtowers are really important if you're like a mobile app and stuff like that. If you're a light client, you may be less reliable. On the server side, watchtowers are probably not such a high priority for us because we tend to be talking about deployed infrastructure. You're not going to have like a 1 week downtime. But watchtowers are definitely coming in general, and I hope to see an open specification for watchtowers. If not, I'll have to write one, so that we can all interoperate and we can all share watchtower infrastructure. Because ideally, the purpose of watchtowers is not so much that they do anything, but they kind of have to exist. A watchtower is a fallback, so that if you and I have a channel, you're not going to broadcast an old state that's in your favor, because you know the watchtower will, for all you know, I'm using a watchtower, and the watchtower will, penalize you even if I'm not online. So the watchtowers need to exist, but because you don't know if I'm using a watchtower or not, they have a preventative power just by existing. So it's kind of an interesting game theory that you need watchtowers to exist. You need them to be out there, but you don't actually need a huge number of them. You just need them to be reliable enough to discourage this kind of cheating attempts. And Coinjoin channel opening, oh wow. So in 0.7.1, the last release of C Lightning, we actually exposed the infrastructure to separate channel openings. So you can actually fund a channel from an external wallet, which opens the door to doing things like a Coinjoin directly into a Lightning channel. As far as I know, nobody has implemented that, but that's the perfect kind of thing to write a plugin for, right? And this is where we increasingly see ourselves implementing infrastructure at the low level and letting people implement plugins that use it to do really cool things. So I would love to see a Coinjoin channel opening. Somebody also has a demo of doing single transaction, multiple channel opening, which would have been really useful for me the other day when I was trying to open a whole heap of channels for test purposes. So, that's a classic example of something where we had to implement the infrastructure to open things up so plugins could then go on and do interesting things. Like Coinjoins. But in what order they're going to appear? Watchtowers are kind of there today, so I'd say they're first. Coinjoin channel opening depends on when somebody writes the plugin. And splice channels is probably a little bit further down the road, I would say. Okay, so we're going to ask about basic MPP. When are we going to see advanced MPP? Okay, so there's no advantage to advanced MPP. In fact, I think it's a bad idea. So the problem with what the advanced multi-part payment ideas is that you no longer get a receipt. You no longer have the invoice connection. So when you make a normal payment, you present me with an invoice, I get the pre-image, which is a cryptographic receipt, which shows, and I can prove to the world, that somebody paid this invoice, right? Now that's not so important today because the Lightning Network is small and we all kind of trust each other and whatever else, right? But when you look at real commerce, when you start using this thing in anger and between untrusted parties, which is what it's designed to do, having that cryptographic receipt and invoices becomes incredibly important, right? There's no third party sitting between you and the vendor. So you need some way of proving that the payment has been made and what the payment was for. So invoices are incredibly important in the long-term health of the Lightning Network. The problem with the atomic multi-part payments as originally proposed was that there's no longer an invoice connection, right? So instead of them revealing the secret to you in return for a payment so that you can use that secret to prove that you paid, you actually provide them with the secret, right? And this loses the ability to prove that you paid it all, right? And that's okay on the current network, but I think in the long run, that is the wrong way to go. So I think actually basic MPP is more powerful in many ways. And there's actually very little reason to do anything more advanced because you lose abilities rather than gaining them. The thing you do gain, however, to be fair, is you obscure the different payments. So if somebody sees two parts of the payments, they can tell that this is the same, that this is actually the same payment at the moment. If you naively split it, then they can tell that the payment hash is the same. So they go, okay, I know this is the same payment going through. So it gives you less ability to to obfuscate your payments by splitting them up into different amounts. That itself is solved by another change that's coming, not even in Spec 1.1, Spec 2.0. Scriptless scripts allows you to basically then decorrelate payments altogether. And that's even more ambitious. And that requires, Bitcoin changes that will require like Taproot and things. So, there's another step beyond that where we get an even more powerful ability to obscure payments. Because at the moment, anyone on the payment path can tell that it is the same payment going through. If you see 2 points on the path, you can tell that that's the same payment, trivially. And decorrelating that is also important. So if we get that, then we no longer need these other techniques anyway. So base amp is actually quite a powerful technique. Okay. Right. Oh, Lyle asked about how far away are we from being able to transact liquid tokens? Okay, via C Lightning. Ooh, okay. So this is a really good question. Christian has done the legwork to integrate elements into C Lightning, but he did it for LBTC. So it's very simple. It basically changes the internal formats to the elements format. Obviously, the transaction format for liquid elements is different, has confidential transactions, and it's so that all needs to be handled. That work has been done, so we can now do Lightning LBTC. The next step is, of course, to then do assets. In particular, when you're doing Tether, it's an asset on LBTC, and we don't have a timeline for that work. It's not seen as a massive. It's obviously something we absolutely want to do, but it's not something that's like an immediate concern. In practice, Liquid offers people fast enough things that they don't really need the what people see as kind of the killer app of Lightning, which is that incredibly fast settlement. It's not too bad on Liquid. Now, at some point, obviously, this is an exciting area and something we definitely want to do, which is to tie the two together. One of the reasons that there's 3 people at Blockstream working on Lightning, there are 2 reasons really. One is that it is interesting complement to Liquid, right? And we see that in the long term. The ability to atomic swap in and out of Liquid was always something that was mentioned in the original Elements paper, that I think is really, really powerful. But also because this is bringing the whole community forward. So we do a lot of work on the specification itself and editing that and making sure that all the implementations play nicely together and that we all move forward together and we get the best ideas we can. And that for me is incredibly exciting. So we kind of play both parts. And sometimes it's more spec work and like low level work and stuff like that. And sometimes it's more complementary with what we're doing. And at the moment, there's a huge burst of spec activity. So we're mainly focused on all the stuff that's in 1.1, all these cool new features that everyone wants, making sure that they're spec'd reliably and they interoperate and they're all robust. Okay. So hopefully that has answered those 2 questions. Mario, Daniel, how are we going? Are we going to go for more questions? Give a bit of a moment.
Sure, let's do that.
Okay.
Yeah, feel free to ask any questions, anyone.
Yeah. So. Oh, Doge points out autopilot scares me. It scares me too, right? I tried using it the other day, but I tried to neuter it so it didn't do anything, and I wanted it for advice. And I think at this stage, autopilots are much better in that mode. You really want to go, give me I've got some funds. I want to open a channel. Where do you think I should open? Have it tell you where it thinks you should go, and maybe poke around, take a look, and go, okay, maybe that's okay. The idea of autopilot basically taking all my funds. I mean, even though this is like my test node, and that's what the funds are for. I'd hate to come up one day and discover it's like wildly just created and lost, and torn down channels, and because it's gone haywire, and I've lost all my Bitcoin to fees. Yeah, I am also nervous about autopilots. But yeah, exactly on small levels, like doing auto rebalancing, much better. But at the moment, most of our plugins head towards, at least by default, being more conservative. So they'll give you a suggestion, right? And then you'll go and do it manually. And if you want to close that loop by writing a cron job that every minute asks for a suggestion and implements whatever it says, then that's up to you. But I think at this stage, we're still in that kind of, and this is a disclaimer that I should have made at the beginning. Lightning's still like alpha and beta software, depending on where you are in the spectrum, right? So you should never put more money than you're prepared to lose into your Lightning node. With the recent, over the last few months with the price increase, I'm probably guilty of doing that myself at the moment. But fundamentally, this is software. Software breaks. Stuff happens, and I really want your bug reports, so I want you to test it, but I don't want your tiers. So small amounts of money are good. Playing around is great, but putting your life savings into a Lightning node is not going to end well. So just be warned. Cool. Okay. I think we've hit the 1 hour mark. I hope you've enjoyed this. I know it'll be uploaded to YouTube afterwards. And thank you, everyone, for the excellent questions. I think that really helped. Okay. Ciao. We should definitely do this again.
Okay, thank you, everyone. Thank you, Rusty. Appreciate you coming on and walking us through C Lightning.
Fantastic. Now I'm desperately in need of a coffee.
All right.
Thanks for coming in, everyone. Thanks, Rusty.